Okay, this is the chemical bonding video. Just to get started, we're going to talk a little bit about the difference between compounds and elements. So an element would be like pure sulfur. So there's only one type of atom in that element. A compound is going to be two or more types of elements that are chemically combined. So an example of that would be like copper and sulfur. If you mix those together, you get copper sulfate. Now, one thing that you need to know, whenever you combine elements, it's going to change the properties of that element. So you can see sulfur here is kind of yellow colored. Copper has that copper color to it. But whenever you combine those, it actually makes it into a green color here. So the Statue of Liberty, made out of copper, has actually reacted to some of the sulfur that's in the air, and it turned it green to create copper sulfate, and it actually protects it from the weather. So it's actually a good thing. Keeps it from rusting and things like that. When we look at our periodic table, we have a couple different groups in the periodic table that we need to separate them into. So let me find a good color here. So on your periodic tables, if you haven't already done that, go ahead and draw this stair-step line, and it basically separates our metals from our non-metals. So over here in the blue, we have our metals, and then in the yellow, we have our non-metals. I don't know if you can see that too well. So those are our non-metals, and then in the pink, we have metalloids. Metalloids are kind of in between those. There we go. We have our metalloids. Metalloids have both traits of metals and non-metals. So whenever we're combining things and we're creating our compounds and we have chemical bonds going on, if we have two non-metals that are combining, we are going to have a covalent bond. It's going to form a covalent bond. If we have two metals, that actually forms metallic bonds, but we're not going to talk about those too much. We're just going to focus on covalent and then ionic bonds. Ionic bonds form when we have a metal and a non-metal. So those would be ionic bonds. And that's where one of them is going to give away electrons, and then one's going to take electrons. Covalent, they are sharing electrons. And a chemical bond, basically a chemical bond is the force that holds atoms together. And when we have covalent versus ionic bonds, there's two different things happening here. So this would be a good example of a covalent bond would be H2O. So we have hydrogen, two hydrogens, and one oxygen atom. So this is going to be covalent. And then we're sharing electrons in a covalent bond. So you can see hydrogen has one. This would be hydrogen's electron. This would be one of oxygen's. And they're actually sharing those two, that pair of electrons. On this one, there's that hydrogen. This is one of oxygen's, and they're sharing those electrons. In an ionic bond, we talked about this in class, in an ionic bond, one of the atoms is giving away an electron. So this is sodium. Right now, sodium has one valence electron, so it wants to get rid of that electron. It's going to give it to chlorine in this case. So chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons, and it's going to gain one more to get its 8 valence electron. Sodium, on the other hand, is getting rid of this one. So underneath it has 1, 2, 3, 4, 5, 6, 7, 8, and it has a full outermost energy level. Now what that does to each atom, it creates an ion. An ion, which we're going to talk about here in a second, is just a charged particle. So this becomes positively charged because sodium had 11 protons and 11 electrons, but now since it gave one away, it only has 10 electrons. So now the overall charge is a positive 1 because protons are positive, electrons are negative, leaving it with a positive charge. Over here we gained an electron, and so chlorine had 17 protons. Now it had 17 electrons. Now it has 18 electrons because it gained one. So electrons are negative, protons are positive. Now the overall charge is a -1. We just write that as a negative sign. for that one. One of the things to look at whenever we're talking about ions, again, an ion is just a charged particle. It can have a positive charge or a negative charge. If we're talking about a positively charged ion, we call that a cation. If we have a negatively charged ion, it's called an anion. So you got to know those names. It'd be good to write those in your notes. And so an anion is going to have a negative charge. Cation is going to have a positive charge. So you can see those. Covalent bonds, those attraction forms when they share electrons. So a good one is water. If we looked at the electron dot diagram of this one, we can kind of look at these two things and how they're sharing them. Oxygen has 6 valence electrons, so actually only 1, 2, 3, 4, 5, 6 of these are oxygens. The other ones are hydrogen. So hydrogen only has 1 electron, right? But they're sharing this, they're actually sharing this pair right here. So when they're sharing one pair, we draw them as just a single line. So one thing to know about covalent bonds, we can have single bonds, double bonds, or triple bonds. So a single bond would just be a single line, and that's one pair. That equals 2 valence electrons right there. So if we counted them up for oxygen, we'd have 2, 3, 4, 5, 6, 7, 8 for this line right here. So we're getting 8 for our total number for that one. Remember, hydrogen's in the first energy level, so it only needs 2 to have a complete outer energy level. So it has its 2 there. A double bond is going to look like this, and then a triple bond would look like that with 3 lines there. Okay, so there are 2 different types of covalent bonds, polar and nonpolar. Polar bonds, like water, is an example of a polar bond. Carbon dioxide, what trees give, or what we give off whenever we breathe out, is carbon dioxide. That's an example of a nonpolar covalent bond. The difference is polar bonds are actually when they're shared unequally. So there's an unequal sharing of the electrons. Nonpolar bonds, they are shared equally between the electrons. So to kind of show you that example here, if we looked at, it's kind of a tug of war between the different atoms. You can see oxygen's kind of a bigger atom, so the size of the atom matters. The charge of the nucleus, or how many protons they have. So if we looked at oxygen, it has how many protons? It has, let's see, 8 protons, right? 8 protons that are positively charged. Hydrogen has 1 proton that's positively charged. So basically we have 8 protons. Remember, opposites attract. So these positive charges are pulling on these negatively charged electrons, right here. And so there's an unequal sharing of that, because these protons are going to pull harder in this direction, these electrons to this side of the atom. What's left on this side, we have the nucleus of hydrogen and hydrogen, so it ends up being like a positively charged side on this end, and then we have a negatively charged end on the other end, because these negatively charged particles are being pulled toward this direction, and leaving a positive proton side on this side. So what does that do with water? It kind of gives it some of its traits here, actually. So if we have, you can kind of see on this one, this would be the oxygen, and it's going to be negatively charged. We have an attraction between the positively charged end of hydrogen. And those actually form what are called hydrogen bonds. It's a really weak bond, but that's why you can actually, like, if you hit a puddle of water, why the water will break into multiple puddles of water, because it's a weak bond. It's only a bond between the positive and negative ends of each molecule. That also allows water to, it's easy to form, but it's easy to break. It also allows water to kind of combine really easily. So that's kind of what gives water its traits. It's a polar molecule. Okay, so chemical formulas, whenever we're reading those, the symbol represents whatever element we're talking about. Then you have these numbers next to them. They're subscripts. Subscript meaning written below. That tells you how many of each one we have. If the symbol doesn't have a subscript next to it, sorry, let me go back to that. If it doesn't have a subscript next to it, then that means that it's just equal to 1. So it's 1 oxygen in that case. Otherwise, this would just be 2 hydrogen. We have 6 carbon, 12 hydrogen, 6 oxygen in this case. So that's how you read your formulas. In this one, if we have SiO2, we have 1 silicon and then 2 oxygen. This would be 1 magnesium, 1 oxygen, 2 hydrogen, so and so on. You can kind of pause this if you want to go through these and kind of write out how many of each one to get some practice. Okay, so I'm going to run through these really quick. This is what we're going to see in the relay and what you guys are going to have to do in the future. Using the electron dot diagrams, we're going to have to bond these things together. So magnesium, if we look at these, how many valence electrons each one has? Magnesium has 2. Bromine has 7. So bromine wants to take 1, right? So it wants to take 1 electron. And then bromine wants to give away 2 electrons, right? So I know if each bromine can only take 1 and magnesium wants to give away 2, there's got to be 2 bromine in this case. So we're going to write magnesium in the middle. We're going to have a bromine. I'm going to go ahead and write it on either side. There's going to be 2 bromines. Now, what you guys are going to have to show me, if we're talking about ionic bonds, they're giving away and taking electrons. Covalent, they're sharing. So in this case, we draw our valence electrons around for our electron dot diagrams. So this has 2, bromine has 7. It may take a little bit of time here. And you do that for each one. So it's going to look something like this. Okay, so magnesium wants to give away 2, so it's going to give 1 to this bromine. And it's going to give 1 to this bromine. So now both these bromines have 8. It has a stable electron configuration. Underneath these 2 valence electrons, we didn't draw it, but underneath there's a complete outer energy level as well, giving it a stable electron configuration. So what is our formula for this one? MgBr2 would be that one. Going to covalent bonds, so let's do some of those. Okay, so chlorine and carbon here, or carbon and chlorine I should say. Carbon is in group 4. It has a plus or negative 4, depends on what it bonds with. So chlorine has 7. It wants to take 1 electron, right? So it wants to take 1 of these electrons. This wants to either give away or take 4 electrons, but since this one wants to take, we're going to give away 4, right? So to do that, or sorry, we're not giving away or taking, excuse me, we're sharing in this case. So carbon has 4 electrons. It needs to share 4 pairs here. So in order to do this, we have the 4 valence electrons. Chlorine can only share 1 at a time here because it only needs 1 more, right? So if we have chlorine, we're going to have to draw 4 chlorines on each side. Okay. So it has 1, 2, 3, 4, 5, 6, 7 basically, and so this is gonna be your single bond in between them. Each one of these is gonna have a single bond in between them, like that, and then you're gonna draw the rest of the valence electrons all the way around it, and that's gonna be how you're gonna do these. So for ionic bonds, you always draw the arrows like up here, and then for covalent bonds, you have a single bond, double bond, or triple bond that you're gonna be drawing in between them, depending on what they need. So for this one, it's going to be CCl4, and that's how you're going to do these. Notice I did not do this one or this one. Those are for you guys to do, so you can do some practice here as you watch the video. So I'll see you guys in class next time. Practice this stuff. Take notes over the video.